Hi guys, welcome to Apollo 1. In this quick video, we're going to talk about subtraction of numbers in other number-based systems. So let's start by subtracting numbers in base 2. So let's do this example. So 10011 in base 2 minus 1101 in base 2. This is our first example. So we start by writing down our number. So 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1, it can go, right? 0 minus 1 again, it cannot go, right? So it means that we have to borrow. We have to borrow 1 from this side. So borrowing 1 from this side, we cancel this 1. Here remains 0. And we borrow 1 to put on this side. Well, this thing I'm about to say is very important because we are operating in base 2. Whenever we borrow 1, we don't actually borrow 1. The 1 becomes 2. Anything we borrow automatically becomes 2 because we are operating in base 2. So as we have borrowed 1 here, this 1 automatically becomes 2 because we are doing our operation in base 2. So this side also needs help, right? So we cancel this 2. Here remains 1. We borrow 1 again, which automatically becomes 2. So let's continue our operation. 2 minus 1 is 1. 1 minus 1 is 0. Then we bring down this 0 here. So therefore, our answer becomes 110 in base 2. So this is our answer. So let's take another example. Let's do this operation. Let's do 712 in base 8 minus 334 in base 8. So 712 base 8 minus 334 base 8. 2 minus 4, it cannot go because 4 is greater than 2, right? So 1 minus 3 cannot also go. So we have to borrow 1 from this 7 here. So we cancel this 7 here, it remains 6. To borrow 1 from this 7, don't forget the 1 automatically becomes 8. Why? Because we are operating in base 8. So the 1 we borrowed from this 7 automatically becomes 8. So I write down 8 here. This side also needs something. So we have to cancel this 8 again. Here becomes 7. We carry the 1 here, which automatically becomes 8. Just whenever you borrow a number, it automatically becomes the base you're borrowing it in. So 8 plus 2 is 10. 10 minus 4 is 6. Then for this side, 7 plus 1 is 8. 8 minus 3 is 5. Then for this last side, 6 minus 3 is 3. So therefore, our answer becomes 3, 5, 6 in base 8. Because it is in base 8 we are operating in. 3, 5, 6 in base 8. So let's try our last example. For our last example, we do 55 in base 16 minus 47 in base 16. So 55 in base 16 minus 47 in base 16. So 5 minus 7 cannot go, right? Because 7 is greater than 5. So we move over to the next side. So from this side, we can borrow 1 from this 5. So we cancel 5. Here remains 4. We borrow 1 to this 5 here. And don't forget, because of we are operating in base 16, the 1 automatically becomes 16. So here is 16. So this operation becomes 16 plus 5. 16 plus 5 is 21. Then 21 minus 7. 21 minus 7 is 14. But as we know, in the hexadecimal or the base 16 system, we not only use numbers from 0 to 9, but we also use alphabets A, B, C, D, E, and F, where A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So as we can see, the number 14 is represented by the letter E. So instead of writing 14, we write E. So we just write E over here. Then for this last side, 4 minus 4 is 0. So therefore, our answer is equal to E base 16. So this is our answer, E base 16. Alright guys, that's it for this video. Please like and subscribe to this channel if the video was helpful, and you can also comment if you did not understand something I said in the video, or if you'd like me to answer any questions regarding the topic or any other topic, please put it in the comment section.